So I am Colin Grabowski,
I'm Ali Hassan.
and we are at the University of British Columbia in Vancouver, BC Teacher Education Program.
So when we first got the syllabus for our program at UBC, it was a little surprising to see that we had to do some math art. And what it entailed was we were shown some artwork that had been at the Bridges 2016 gallery. One of the choices that stuck out to me was binary art called Kandinsky and binary.
Yes, that's right.
So the Chamberlain's original artwork was done in base 2, binary. They were not assigning any specific meaning to the different colors. So every color was 1, and the lack of color, white, would have been a 0. So the first thing that we thought of was just to change the bases and see what would happen when we turned it into a base 3, a base 4, base. So we only had 3 circles, and then we just put that together and see how would that look the same or different from the original artwork. And it was interesting seeing some of the patterns were re-emerging, but there were also some unique patterns to the new shape. And just looking at it, you can kind of see different kinds of symmetry coming out of the artwork.
We talked about how we would be able to extend this for classroom activities so that students would be able to create with this. So one of the ideas we thought of was to have a blank template where they could create this using their own sort of colors. So this is an example of one that's been started. And so this could be used in teaching subjects like Math 8 or 9 or computer sciences whenever people are studying number bases or binary.
The fun things about this is that you started off with an idea, a mathematical idea, but you don't know what your end product is going to look like. And as you're working on it, you start seeing things. But they can explore it and find lots of different things themselves. And of course, they can just do a sort of reverse engineering and say, okay, well, that's what the colors are doing. What are the digits doing? How do the digits interact with each other?
So when I first saw it, it looked to me like film strips. Immediately I thought to myself, what is this going to look like if it was animated? I simply used a video editing program where I got all these photos that I had made and put them in from 0 to 63. And then I thought, well, let's go backwards and go from 63 back to 0 and see how that changes. I'm not very musical, so I decided to go with the most simple treatment of music that I could think of, and that would be if these circles were like keys in a piano. We've taken a little arithmetic problem there, and this is similar to the grid that we showed. Instead of having all the numbers, we're just going to pick some numbers and see what happens artistically and how that helps us intuitively understand. I'll just write some numbers there in base 3. So I'll just pick some colors. I'll see what happens when I add those numbers together. And, if I do this enough times, I might learn something. So got the 2s, and oh, this is going to be 2, so I'm just going to color outside the lines here. And then the number 1, the pink, so I've got a pink in here. And I also have a pink in here. All right, so what have I done? What kind of patterns do I see? Well, got red and white makes red. I got white and red makes red. I got pink and pink makes red. I've got some ideas now. Maybe I can try a few different sums and see what I come up with, and maybe that'll help me understand a little bit more about how numbers add together. What happens when I add numbers together? If not using numbers, I use colors. What is that going to look like? And that's an interesting way of just understanding everything that's going on in mathematics. It's kind of a nice, beautiful pattern, and it's also, this is the underlying nature of life. All this works. Everything in the world is based on this. It's kind of overwhelming to think about that, and this is something so simple.